Good morning. Thanks so much for joining me. So this talk is about the lost art of software design. It's an essential piece of the software development process, of course, but fewer teams seem to be doing it these days, or at least doing it well. And that's really what we're going to talk about. So of course, over the past decade, maybe 2 decades really, teams have thrown away big design up front. This is the agile thing, and of course a huge reaction to the waterfall processes of the 80s and 90s. And that's a good thing. There's lots of waste associated with big design up front. However, many of these teams also threw away a bunch of really important stuff that became unfortunately coupled, very tightly coupled, to big design up front. I'm thinking of diagramming, documentation, and really architectural thinking and the process of doing design well. There's a great quote I like to use that really epitomizes what I've seen over the past couple of decades. Big design up front is dumb, but doing no design up front is even dumber. And this is a fantastic quote because it represents that silly thing we see time and time again in our industry where we flip from one extreme to the complete polar opposite. Now you might be thinking, well, hang on a second. Agile approaches don't say don't do upfront design, and you're entirely right. And of course, what many teams are trying to do is they're trying to do evolutionary architecture or emergent design, where we're doing a little bit of design. We're spreading it out amongst the entirety of the software development lifecycle, delivering features all the time, of course. The thing is, that's hard to do. So there's a great book on building evolutionary architectures that I would certainly point you to. And there's lots of tips and tactics and strategies in this book about building architectures that are able to change easily. But it's hard. It's really hard because the thing people don't really appreciate is even when you're making design decisions on a continuous basis, some of those decisions you end up making are actually quite significant and they're hard to change later. And if you get the ordering of some of these decisions wrong, you end up accumulating quite a lot of technical debt very, very fast. I want to caveat this session by basically saying when I'm talking about design, when I use the word design, I'm really talking about the technical aspects of software design. So it's choosing technologies, it's choosing whether we want to do monolith versus microservices. There's a whole discipline around product-focused design. User workshops and UI and UX and A/B testing and all that stuff. Right, that's super, super important, but that's not what I'm here to talk about today. So I'm going to basically tell you the conclusion of this talk because I want to be very, very upfront and explicit about what I'm about to talk about. So I want to do 2 things. I want to explain why some degree of upfront design is useful, and I'm going to share some tips on how you can do that more effectively. And I want to dispel a bunch of myths, essentially. So for those of you who don't know me, my name is Simon Brown. I'm an independent consultant. I live in Jersey in the Channel Islands. That's the old OG Jersey, not the new Jersey. And pre-pandemic, I used to fly around the world and run software architecture workshops. I'm the author of a bunch of books, and if you go back into my past, I also authored some Java books and JSP books. So these architecture workshops, they're basically in the form of architecture charters. So what I do is I take the attendees, make them into groups of 2, 3, 4 people, give them some requirements like this, and I say, right, you've got 1.5 hours to basically do some design. I'd like you to do some design and to draw some diagrams to really showcase your solution, describe your design. And we do this in a couple of iterations. Iteration 1, we get exactly what you think we get. We get a whole bunch of crazy looking diagrams. And we have something to build on here, but I want people to really understand why these diagrams are not great. So something we do is something called the perfection game. And what we do is we get the groups to switch diagrams, and I say, right, now you're looking at a set of diagrams you've never seen before. What I would like you to do is to review that set of diagrams. What do you like? What do you think can be improved? And ultimately give the diagram a score between 1 and 10. So this is the type of diagram that we get. It's okay. Doesn't really tell you much about the solution. This diagram scored a 7. This diagram also scored a 7. As did this one. You can see a pattern already, can't you? That one, same thing. 7. 7. These are all of the diagrams from a single workshop, by the way. 6. Ironically, this one has a bit more detail, and I think that detail put these reviewers off. So those are the types of diagrams that we typically see during the first iteration of the workshop. The 7 out of 10 thing is kind of interesting. Most people give a 7 out of 10 because it's like not mean and it shows some room for improvement. And it's a bit vague and ambiguous. It's like a nice safe score, especially when you're reviewing and rating your colleagues who you have to work with afterwards. So we review this, we do a bunch of stuff, and we drop into iteration 2. Now, iteration 2 is basically I introduce my C4 model for visualizing software architecture. We show some example diagrams, some example diagramming tips, and guess what? We get some nicer diagrams. So this is an example of a C4 model system context diagram. I'll talk about this a little bit later on, but it's nice. We can see there's a system in the middle, a couple of different user types, some system integration points. We've got some detail on here. It's nice and neat, it's readable, has a key, a legend, etc. And then there's a container diagram, which kind of zooms into the system and shows the applications and data stores that make up that system. And the world is a better place. And at this point, people say, well, hang on a second, so your workshops are basically teaching people how to draw nice diagrams. Yes, but in order to get to nice diagrams, there's a bunch of things we have to go through first. And really, that's what this talk is about. How do we get to the point where we can create nice diagrams? What things do we need to think about? So we're going to cover a bunch of topics. The first of these is upfront design. Now, whenever I talk about upfront design in conference talks and in workshops, I get a lot of resistance pretty much immediately, especially from those teams who have gone through their agile transformations and they're like, yeah, we're agile. And I have people literally asking me this, we're an agile team, are we allowed to do upfront design? Like, oh, okay. I've had people say that we do extreme programming, so we don't do upfront design. To which my response is always, well, how's that working out for you? And they're like, it's not good, that's why you're here. I get lots of teams saying, yeah, we're agile. Upfront design is not expected in agile, of course, except it is. There's nothing in the Agile Manifesto that says don't do upfront design, so where did this come from? And the answer is, if you go dig through the literature on extreme programming and various agile techniques, you'll see people saying stuff like this, there is no big design up front. Design activity takes place on the fly and incrementally. Again, kind of pushing people towards the emergent design evolutionary architecture thing. Another one here from Martin Fowler. It's got lots and lots of words in here, but putting more and more energy into avoiding any upfront architectural design. So again, luminaries of the agile world here kind of pushing people away from doing upfront design, which is, it's a reaction to a lot of the waterfall stuff that went before this, but maybe taking this at face value is not the best way to do things. One of the things I really dislike is that you rarely see these agile luminaries, and particularly the people behind the Agile Manifesto, explicitly come out and say there are benefits in doing upfront design and you perhaps should do some upfront design. But the problem is they're not saying, it's kind of easy to read into what's not being said. Because these people are not talking about upfront design, it's very easy to misinterpret their messages. You should not do upfront design. That's what I'm trying to say here. Those people have a lot of experience, like a ton of experience. Probably way more than we'll ever have. And most teams today, because software development is growing so fast and exponentially, the teams we have today do not have that same level of experience. Now, I always wondered, what would happen if you took the Agile Manifesto signatories out of software development and put them into a discipline that they know nothing about, or much less about. And this happened on Twitter a little while after I had this thought. So Kent Beck decided he was going to take some time off and write a book. And he posted, upside down, I don't know why, but he posted a photo of the outline of the book he was planning to write. And somebody picked up on this, and they said, interesting that you write an outline first. My daughter kind of just writes and does refactoring, which is what he's basically promoting with extreme programming and code, of course. And Kent basically said this in response: I need to see a whole. He wants to get an overview of the thing he's creating, which in this case is a book. And that's how I feel about software development. If I'm taking a blank whiteboard and a team of developers, and we have a set of goals to meet, a set of features to try and build, I can't just rush in and start coding. I need to step back and say, right, what are we building? Who's using it? What sort of things they want to be doing? I want to get some sort of overview. And that's really what this is all about for me. How do we get to this overview? Well, it turns out that the agile and agility, it requires a toolbox of practices. There's not a single silver bullet solution. There's not a single way to do this. It requires a toolbox of practices. And I think we've stopped teaching people how to do design well. Next time you go back to your office, hopefully you're back in your offices, ask your colleagues this question: how do you design software? If somebody gives you a set of requirements, what do you do next? And there'll be a pause and people go, I've not really thought about this before. And you'll often get answers back like, we use a whiteboard. Okay, so you use a whiteboard to do design, perfect, but what are you using the whiteboard for? I mean, whiteboards can't do design themselves. Like, well, we're drawing pictures, we're drawing boxes and lines. Well, what do the boxes and lines mean? Well, I have a whole talk about that. You say, well, the boxes represent components. What do you mean by component? And there's a whole bunch of stories and questions you have to kind of go through here. And in the end, people end up saying, well, we just use our experience. And that's kind of right, isn't it? We are using our experience, but this is not a great way to explain to people, especially new people, graduates, for example, the process that we are going through in our minds to take a set of requirements to a solution. And it turns out when you tell people, there's a bunch of documentation and books around this. You talk to people about different strategies for decomposing software into modules or building blocks or microservices. There's a whole bunch of different strategies out there. If you've been to any microservices talks over the past few years, you would have undoubtedly seen this. This is the classic Parnas paper. It talks about modules, but it's equally applicable now to things like service-based architectures. And of course, you got some of the older techniques like classes, responsibilities, collaborators. This is a fantastic visual and collaborative design approach that you can use. So at the time, this is focused on classes, but you can use this for components or systems or services. So you can take the same approach and use it at different levels of abstraction, different levels of modularity. I think one of the problems people have, one of the misconceptions people have about upfront design is they think it's about creating that perfect end state. Like, we're going to craft up a blueprint. You'll often hear the word blueprint, of course, and that's what we're going to aim for. And for me, that's not what we're doing upfront design for. We're not trying to create a perfect end state. We're trying to do something else. I like this image. It's from a blog post called Evolutionary Design Beginning with a Primitive Whole by Josh Kirievsky of Industrial Logic. We've seen this 1,000 times before. This is you want to build a nice sounding guitar. How do you do it in chunks? How do you do it iteratively? Version 1, minimum viable product, basic features, add, extend, enhance, get feedback. Right? We've seen this 1,000 times before. What we don't talk about, or at least talk about very often, is how do you get to version 1? In order to get to version 1, in order to get to that initial version that you're pushing out there for some feedback, you need to do some thinking, you need to do some design. You need to put a sufficient set of foundations in place that will allow you to iterate appropriately and add those new features in the easiest and quickest amount of time. And teams don't think about this, and this is why they accumulate lots of technical debt very quickly. They're trying to move too fast, and they're not focusing on the foundations. I'm not trying to design all of the foundations, remember. I'm not trying to do big design up front, but I want to do something. The Agile Manifesto, when you click through to page 2 and you get the principles, it actually says this. Principle number 9 says, continuous attention to technical excellence and good design enhances agility. And I think we've managed to miss this over the past 20 years. A good architecture gives you agility. If I go back to the discussions I had with people 15, 20 years ago, kind of had Agile here and architecture here, and they were competing forces. That's the the thought that many people had. And it's totally the opposite. Agility and architecture are very complementary forces. A good architecture lets you move fast. This makes sense, doesn't it? From a gut feel perspective, this makes sense. If you've ever worked on a very horrible, messy, big ball of mud, spaghetti code base, a distributed big ball of mud, who has those systems? No, don't answer. Those things are hard to work with. It's hard to add features without breaking stuff. It's brittle, it's fragile, it slows you down. If you have a good code base, by which I mean it's well structured, it has a high degree of modularity, not necessarily service-based, but a good degree of modularity. You can make a change inside that box and you don't get that blast radius effect, that ripple effect that breaks the rest of your system. So modularity is a very good way to enable you to move fast. You don't get that for free though, of course. So you have to put some thinking into how do I want to modularize my system? Is it a monolith? Is it a set of services? What features go into each of these blocks? And how do we, compartmentalize those things? So I want to do essentially some degree of upfront design to put a starting point and a direction in place. That direction might change later, and that's fine because the whole point of agility is to get feedback, change direction, and react to external changes. But let's get at least an initial starting point and direction set first. Because that starting point adds value. It anchors the team. It's like, this is what we're building. This is the general direction we're going in. Are we all agreed? Good, let's go. And essentially, this is about technical leadership. So one of the ways I talk about software architecture is that it's essentially about technical leadership. And all teams need technical leadership. You'll see a bunch of people on Twitter saying that teams don't need software architects. They might not need software architects, but they do need technical leadership. Whether that's a single person playing the architect role or you shared that leadership out amongst the team is an orthogonal concern and a different story. It's also worth pointing out that technical leadership exists in many different dimensions across most organizations. Your team is going to have a very different set of things it wants to think about than your enterprise architecture team, for example. They might be looking 5 or 10 years into the future, integration with business partners, which you might not be. So there's lots of different scopes for technical leadership here. So that's my little piece on upfront design. I do want to come back to diagrams now because this is actually a really important part of the story. What happened to UML? Quick show of hands. Who uses UML here? 6, 7. That's not many people. The fact I can count the number of hands is pretty telling. So yeah, fewer and fewer people are using UML these days. It's a tiny percentage, and when I ask people what are you using UML for, it's normally class diagrams and sequence diagrams, and we're done. Why don't people use UML? They either claim they don't know it, or they claim that they are the only person on the team who knows it. It's normally the older people with grey hair like me. I did some consulting. I ran a workshop for a very, very, very well-known company. I guarantee you'll know who it is. And they said this to my face: if you use UML here, you'll be seen as old. Wow. And then it was followed up. Literally the next sentence was, and old-fashioned. I'm like, oh, come on. That kind of screams some interesting cultural issues with this organization. People tell me that UML is too detailed. I mean, UML is just a language. You can use all the language or some of the language, so that's not really a good reason not to use it. This is interesting. We don't want to tell developers what to do. So there's this perception that when you use UML, you are telling people what to do. And again, UML kind of became coupled to big design up front and those horrible ivory tower architects, the astronaut architects. Yup, it's always been bad. There's nothing more to say there. This guy says UML is a very elaborate waste of time. A bit harsh. So what's his alternative? Just use a whiteboard. Wow. I know how this works. Remember, I went through the diagrams I get from my workshops. I've run my workshop for well over 10,000 people in 30 countries. I get this literally every single time I run a workshop. I did a workshop a couple of weeks ago in Europe, got the same types of diagrams. So what's wrong with these diagrams then? Like, why am I picking on these diagrams and trying to make them better? Well, we got the 7 out of 10 thing. Like, people don't know these diagrams are not good because they've not seen better. Something I get my groups to do is, again, swap diagrams and say, right, look at these diagrams and answer these 2 questions. Question number 1, does the solution you are looking at satisfy the architectural drivers? So the requirements and the quality attributes, essentially. And question number 2, if you were the bank, would you buy this solution? And teams go away and do this for like 5 or 10 minutes, and they look very confused, and they scratch their head. And at the end of it, they basically say, no, it's impossible to answer those questions. Why is it impossible to answer those questions? You're software architects, you're software developers, you have a solution in front of you. Why can't you answer those questions? Well, they can't see the solutions. Because the diagrams are horrible, they literally cannot see the solutions. There's far too much visual noise there. And that's a huge problem, because if you can't see a solution, you can't evaluate it. You can't explain it. This forms the building blocks for so much other stuff in the software development process. Back to this. Yeah, people tell me that UML is not expected in Agile, blah, blah, blah. Where did this come from? It's the same stuff. You go look at some of the old Agile literature. This one's here from Ron Jeffries. He says, so question, would it be better if we used a case tool to lay out the design? No. The design is more readily expressed, changed, and understood when done less formally with CRC, so I like CRC, on the whiteboard or a bar napkin. Wow. So we're supposed to be software engineers, and we're supposed to use bar napkins because it's easier to change. Yeah, I don't buy that. More words. You may well need some nicely formatted UML for your project, but probably not. But inside your co-located whole team, you must probably will not need them, because the information you need will be communicated through the more effective medium of conversation. The value is in the conversation thing. I have seen a ton. And I totally get the benefit of doing this. Go back 20 years, it was all exchange of documents across offices, across teams, the architecture team, the analysis team, the design team, the development team, the test team, the ops team, etc., all exchanging diagrams and documentation. It's very wasteful. So again, Agile is a reaction to let's stop exchanging documents and let's have actual conversations. And I totally get that. But the problem is we've taken this to the extreme. Teams are now sketching up really horrible looking diagrams. They're having a quick conversation. They're like, are we done? Do we all get it? Yes. Erase the diagram, move on. And now we don't have those artifacts anymore. And sometimes those conversations are the wrong conversations. Somebody said this to me after one of my workshops. You know, these diagrams produced during iteration 1, they're all excellent as long as there is a conversation about their meaning. It's the accompanying conversation that matters. Who's been working from home for the past 2 years? Yeah, guess what? You can't just walk up to someone and have a nice, easy conversation, because now we've got Zoom in the way and Slack in the way and Teams in the way, and this has whole got a lot harder. So we do need to be careful with this whole conversation thing. And the value in the conversation is a good thing to think about, but it only works if you're able to have the right conversations. And if you can't understand the diagrams, you can't have the right conversations, because there's lots of ambiguity kind of floating in there. So that leads me to superficial amounts of upfront design. So teams claiming they do design, but they're not really doing it well. I've seen a bunch of solutions to my architecture kata, and you've got a bunch of boxes with names in them. And imagine you have like a group of 4 people. Half the group will look at this diagram and say, we have designed a microservices architecture. And the other half of the group thinks it's modules in a monolith. And they've never had that discussion about whether this is a microservice deployable type architecture. I'm like, wow, that's pretty shocking. So again, it's very easy to misinterpret a diagram. Why is the ORM directly connected to the Angular front end? This is a little bit of a very specific question, but this is one of the diagrams I showed you before. We have a JavaScript front end, an Angular front end, and a .NET back end. And there's an ORM here. so something like Hibernate in the Java world, of course, you'll notice there's a link between something running in the browser in JavaScript and the ORM. Like, how do you actually make that work? And again, they never spotted this weird looking link. That's clearly not going to work. Same thing, is the web UI getting data from Amazon S3? I see a ton of people drawing like we've got a box labeled web app, and we have a bucket from S3, and there's a line from the web app to S3. You're like, great. So you're pulling data out of S3 and sticking it on a web page. How are you doing that? Like, oh, there's a JavaScript API, and we can use that to get data from our private S3 bucket. Perfect. Where are you storing your credentials? In the web page. Oh, and again, you have to kind of hand walk them through these conversations because they're not realizing the mistakes that they're making. They will eventually, you know, the second they start writing code, they're like, oh, this is not a good idea, is it? But we can preempt that just by a quick review. This took me like 2 minutes to spot. So what's happening here? People are not engaging in the problem space anymore. They're trying to rush. They're going to their business people. They're going to their customer representatives. They're getting requirements, and they're just trying to start coding immediately. And you see, just like, chill. Take 5 minutes, focus, have a think. What are we trying to do here? And I see teams rushing into this design because they just want to get it done. They want to get it done, go have coffee. And the more agile teams claim to be, the worse this seems to get. And you can spot these superficial designs a mile off. Bunch of boxes, vaguely named, arrows with no descriptions. It's a very generic design. It could satisfy a whole bunch of different use cases. We need to stop, we need to pause, and we need to focus on what is it that we don't know yet. And for me, this is why we do design. This is why we do some thinking up front. Because we have a view of the solution, but it's not the complete view of the solution. And again, I'm not saying we should go and get everything and capture everything, but there's some stuff we can get quite quickly. I like to use the S curve of learning here to explain what I'm talking about. Imagine you're learning a new skill. Initially, your new skill is really hard to grasp. You have to understand the jargon, the domain language, some of the basic skills and steps and techniques, and that can take you some time because it's a learning curve. After you've got those basics down, you find you get into that accelerated learning part of the curve, where you can start to pick up new skills actually quite quickly. And then after your 10,000 hours or whatever, your learning plateaus out. When I see people doing upfront design, especially in the more agile environments, they get stuck right down here. They're doing a very small amount of design and basically not learning that much. And they're like, oh, we'll do emergent design and evolutionary architecture, and we'll learn as we go along. That's fine, but if you spend a little bit more time, you can get into this accelerated learning phase actually quite quickly. And when I talk about doing some design up front, I want people to stop kind of around here. Big design up front took us all the way along that plateau. I don't want to do that, it's very wasteful. But let's at least get people into that accelerated learning part. Because we don't get stuff for free. I see a ton of organizations jumping on microservices and Docker and Kubernetes and serverless and AWS Lambdas, and they're just jumping on these solutions because they think that's what they should do, and they're not thinking about whether these things are most appropriate for their context. George Fairbanks in his books basically calls this architecture and different design. It's an approach to design where you just do something because of hype, trend, and fashion, or because that's what we've always done. And again, there's no thought going into that. Tech decisions. One of the things I notice about the diagrams during iteration 1 is they're usually completely devoid of tech decisions, like programming languages, frameworks, etc., etc. They're very generic. They're like kind of very high-level conceptual logical architecture diagrams. And you ask people, why are you not putting technology choices on your diagrams? And they say, because we don't have enough detail. I'm like, what? Like, I'm stood here for 90 minutes doing nothing because nobody's asking me questions. come find me and I'll help you answer questions. So that's a bit of a misnomer. I have no idea what this means. I've literally had organizations tell me that they don't solutionize. I'm like, hang on a second, I've asked you to do design. Isn't the point of doing design to come up with a solution? Isn't that what solutionizing means? No idea. Our architects are not allowed to do solutioneering, is something another company said to me. I'm like, what? Like, you're using words and they don't make sense. The point of having an architecture role, again, is to put solutions in place. We don't want to impose a solution upon the development team, is something I've had a bunch of organizations say to me, which is kind of interesting. Remember I spoke about technical leadership. We're creating a starting point and a direction. That starting point should really have tech choices in. If you're a Java shop, then you probably want something Java focused. Ditto for Ruby, .NET, etc. So maybe imposing some sort of solution on the team is actually not a bad thing. Maybe you have a company-wide strategy that says we're going to use AWS for everything. So maybe constraining the teams what they can and can't do is a good thing. We leave developers to choose implementation details. Again, a lot of this is a response, a reaction to ivory tower architects telling the teams, you must use this specific set of technologies and frameworks and versions. And the team's going, no, we want to do what we want to do. They want autonomy. And that's fine, but there are trade-offs and consequences with giving complete autonomy. And again, sometimes it's useful to rein those choices in a bit. We're a Java team, so obviously it's a Java solution and we didn't put Java on our diagrams. Well, I don't work for your company, and that's not obvious to me. So again, it's very easy to create these technology agnostic diagrams and view them through your specific lens, which makes sense to you, but it doesn't make sense to external parties. One of the things I've noticed with my diagrams is that you get this interesting conflict. So the people producing diagrams give you all these excuses for not putting tech choices on them, but when you flip the diagrams between the groups, the people reviewing the diagrams like, if these diagrams had tech choices on, they'd be much easier to understand for me as a developer. And I think that's quite telling. So, how much upfront design should we want to do here? Well, the answer is some, and I told you that right at the start, but I want to put some more guidance around this. And I think when you're at the whiteboards drawing a bunch of pictures, doing a design process, and whether this is a greenfield design process or you're taking an existing system and changing it in a significant manner, I want you to be able to answer these two basic questions about what you are drawing on that whiteboard. Question number one, do the diagrams reflect what we think we're going to build? And question number two, is it going to work? We're not trying to decide everything. Remember, big design up front from the late 90s decided literally everything. Very speculative. We might need it later, so we'll make that choice now. I don't want to do that again, but there are some decisions that I do want to make here. What type of decisions do I want to make? I like going back to the Grady Booth's definition of architecture because he says this, architecture represents the significant decisions where significance is measured by cost of change. That's super, super important. There are some decisions you make and they're really, really hard to reverse. Who's ever deployed an app into AWS and then they've been told, no, we're not going to use AWS anymore, it's going to be Azure. Azure. That's a massive change, isn't it? It's like a completely different cloud platform. You can't just lift and shift your code in most cases. So these are things I want to think about up front. My core technology choices, the languages we're going to use, the frameworks that are going to become embedded in the code that we write. You might think, well, hang on a second. We follow the hexagonal architecture and the ports and adapters architecture and Uncle Bob's clean architecture. And we isolate our business and domain code from our technology choices and our frameworks. Right, but you just made a significant choice. The significant choice you made was one around structure and modularity. So there's no getting away from making significant decisions. Sometimes you're making these significant decisions consciously, and sometimes they're just happening for you by default. If you want to change your ports and adapters architecture to something else like microservices, guess what? It's a rewrite. So it's that sort of stuff that I'm really interested in. Martin Fowler said this a long, long time ago on his Blicky. I think there's a role for a broad starting point architecture. And he's talking about how to do layering, so again, modularity strategies, decomposition, how you'll interact with the database if you need one, so something about data storage. Data storage is typically a bunch of significant decisions waiting to happen, and things like web service, how do we handle web requests. So again, this is not everything. This is not designing our entire database schema. It's not designing all of our low-level object models and how we're going to do servicing web requests. But there are some significant decisions that we can make here early. Those things are not going to change much later. Just use a whiteboard, the values in the conversation. We need to get past this. We need to get people having better conversations. And with regards to the diagrams, and I said this yesterday in my talk, this is not a tooling issue. This is something much more fundamental. The way that people are describing their architectures, the way people are drawing their architecture diagrams, it just leaves so much ambiguity on the table. You can't answer that first question with most of the diagrams I see on a day-to-day basis during my workshops and when I go visit organizations, and they show me their real architecture diagrams stuck in Confluence. So we need a ubiquitous language. We need a way for teams to be able to describe and explain their software architecture to other people, both inside their teams and outside their teams, of course. Nothing we do lives in isolation here. It could be UML, but nobody wants to use UML. A lot of people get caught up on notation. They're like, which notation are you using? I think we need to step back and we say, right, what is it you want to describe? What are the abstractions you want to think about? What are the levels of detail you want to use to describe your architecture? And for me, having a common set of abstractions is much more useful today in 2022 than having a standard common notation. And this is where my C4 model for visualizing software architecture comes into play. It's a set of hierarchical diagrams that you can use to describe software architecture at different levels of detail. Think about it as diagrams as maps. Sometimes you want high-level diagrams, high-level maps. Sometimes you want low-level maps to really describe the nitty-gritty detail. And these diagrams at different levels of abstraction allow you to tell different stories to different audiences, some of whom might be technical, some of who are going to be non-technical. And it's notation independent, so I'm not promoting a single unified notation here. What I am promoting is a common set of abstractions that you can use to describe your software systems at different levels of detail. And it turns out these diagrams, apart from looking nice, they're great checklists, they're great visual checklists for a lightweight design process. The system context diagram. The system context diagram basically shows you the system you are building in the middle, the different types of users or actors or roles or personas that use your system, and the various system integration points that you need to support. So in order to draw a system context diagram, you have to answer those questions. What's the scope of the system we're building? What features live inside it? What features live outside it? Who's using the system? What sort of things are they doing? And what system integrations do we need to support? Once you answer these questions, you can draw a nice system context diagram. And sure, I have a bunch of tips on how to make your diagrams visually look nice, but the content is what we're really looking for here. So in this example, we can see that this group decided to make a design for a financial risk system. They identified a couple of different user types, and these are all of the system integration points. So that's a really nice starting point. Now we've answered a bunch of scoping type questions. We zoom into that system context diagram. We zoom into the software system and we draw a container diagram. And again, it's the same thing. In order to draw a container diagram, we need to ask a bunch of questions. What are the major technology building blocks? So by container, I don't mean Docker. That's an unfortunate clash of naming. Basically, a container, a C4 model container, is an application or a data store. So what applications and data stores do we need to build to make our system function? What are the responsibilities of those applications and data stores? How are we partitioning functionality across our architecture? Again, this is that whole conversation about modularity and decomposition. And how do these different parts communicate? Is it in process? Is it out of process? What protocols and stuff are we using? Answer this set of questions and you can draw a container diagram. Again, this is a zoom in of that red box I showed you before. It's showing a couple of React and JavaScript apps. There's a Java Spring app, and there's a bunch of data stores with some command line applications as well. And this is a really nice diagram that I think quite adequately shows and presents the architecture of this particular solution in some detail. We've got some tech choices on here, and so on and so forth. Because I'm asking teams to answer these questions, they're having to do a little bit more thinking. You can't draw this diagram without doing some thinking. And these diagrams need to spark meaningful questions. So next time you look at a bunch of diagrams, if you're asking yourself, what do the arrows mean? Why are some boxes blue? Why are some green, etc., then the diagram is not good enough. I don't want to be continually answering these stupid notational questions. I want to push that to one side. I want a nice key and a legend to explain my notation. I want to use a self-describing notation. I want to ask and answer these types of questions. Oh, I can see very clearly you have two Java apps and there's a line between them. How are they talking to one another? Is this like a RESTful JSON over HTTPS thing? Or is it maybe something more asynchronous with a message bus in between? Oh, I can see a cylinder and it says Mongo, but we don't use Mongo here. Why have you chosen Mongo? I want to see the solutions, understand the solutions, evaluate the solutions, and then challenge the solutions where necessary. These diagrams lead to richer design discussions. One of the things that happens during the workshop is during iteration 1, people draw a bunch of diagrams and they look horrible. And then during iteration 2, many of the people think this is just a redrawing exercise. But of course it's not. In order to draw the nice diagrams, you have to do more thinking. You have to have richer design discussions. Oh, now we've got two Java apps. How do they talk to each other? How are we choosing to partition functionality across this one versus this one? The groups have to go through this set of questions. Scaling teams is a big problem I see organizations having, particularly with this whole pandemic and teams working remotely and from home. And of course, better diagrams allow you to scale teams. It allows you to scale knowledge and information out to wider audiences in a much more efficient manner. You can do the just use a whiteboard, the value is in the conversation, but of course, every time you want to have a conversation, you have to go redraw the diagrams. Are you going to redraw the same diagram every time? Nope. Is that a good thing? Maybe, maybe not. I also want these diagrams to provide meaningful feedback. I have seen a bunch of people, so the set of requirements for this Carta, they're very straightforward. It's like a little financial risk system. I've seen a number of groups try to design this with a serverless style architecture in mind. So you have a whole bunch of AWS Lambdas sending stuff to DynamoDB, DynamoDB triggers, triggering Lambdas, and this is a horrible mess. And people often ask me, we're trying to diagram our serverless architecture, but our diagram is getting complicated. What's your suggestion? And my answer is, simplify your design. Right, if you have a complicated architecture with lots of moving parts, you're going to get a complicated diagram with lots of moving parts. It's just reflecting reality here. So the better answer is, are you sure this is an appropriate solution given the complexity of what you're trying to do? So the C4 model diagrams allow us to answer that first question. So that's one of the reasons I'm a big advocate of these diagrams. Once you start adopting these diagrams, it makes a bunch of other stuff much, much easier to do. The diagrams still don't answer that second question though. Scott Ambler has a great essay on Agile architecture, and he says this: you should base your architecture on your requirements, so both functional and the quality attributes, travel light, so yeah, just do enough, be agile, and prove your architecture with concrete experiments. And that's really the other part of this equation, of course. A lot of this is risk-based. I get many people saying, Simon, how do we deal with risks in Agile projects? And my answer is, go and read the Rational Unified Process book from 20 years ago. Because we've solved this problem before. You front load the risk. You get the risky stuff out of the way, you run some proof of concepts, some prototypes, some concrete experiments, and your life becomes slightly easier. Risks are very subjective though, based upon your experience. Estimates are exactly the same. So one of the things I urge teams to do is to remove the subjectivity around the risk identification process. The thing you don't want to happen is the single architect on the team coming up with the list of risks that need to be addressed, because then you only get that one person's view of the world. And they might be right, but there's so much more value in asking the whole team and making this a whole team thing. So I have a technique you can look up. You can go to riskscoring.com. And it's a visual collaborative way to identify risks. And this is one of my key processes I get teams to do. It's a little kind of gamey type thing. It's inspired by game storming and innovation games, if you've seen those books. And it takes 10 or 15 minutes, and it's a fantastic way to get a list of risks very, very, very quickly. You're basically sticking sticky notes on a set of diagrams. If you have a good set of diagrams, we've just talked about that, it makes the risk identification process much easier. I see lots of teams doing threat modeling these days, and the whole like DevSecOps and threat modeling is becoming more popular, more relevant. There's a bunch of threat modeling techniques out there. Again, if you have a good set of architecture diagrams, it becomes much easier to do things like threat modeling, both on the static structure of your solution and also the deployment architectures. So yeah. Think about doing things like stride on top of the C4 model diagrams, both static structure and deployment. We're going to be making decisions whilst we are doing design. There's a bunch of work around architecture decision records, ADRs. You can find the link there, Michael Nygaard. I see more and more teams adopting a nice lightweight process, a nice lightweight technique, an approach for capturing significant decisions. And this is super, super useful because it stops you reinventing the wheel, and hopefully you can start to write down some of this stuff in a nice lightweight way. We chose X because of these reasons, but there's a potential consequence here. And you can track when you start superseding and deprecating decisions when you learn more and change. So how much upfront design should you do? I asked this question on Twitter a while back, and somebody said this to me. If I have like a 1-year development effort, I'm good with 1 day of design. Wow. I mean, that might work for them, it's not going to work for me. And it depends what you're building and how complicated it is and how big your team is. So let's not go with a number of days per development effort, because that doesn't make any sense. I like to think of upfront design as being an iterative and incremental process. So let's ask the reverse question: when do you stop? When do you stop doing thinking and drawing and diagramming? And when do you start writing code? If you understand your significant architectural drivers, so these are your importance requirements, your high-level importance requirements, your significant quality attributes, scaling, security, performance, etc. The constraints you're working within, once you understand this stuff, you're in a good place. If you understand the context and scope of what you're building, you're in a good place. So if you can adequately draw a system context diagram, you can answer those questions. You understand your significant design decisions. Again, this is the modularity, decomposition, technology decision thing. If you can draw a container diagram, you're in a good spot. You can answer those questions. If you have a way to visualize these things and communicate your intent and your starting point, remember this is about creating a starting point. If you have a way to showcase that starting point to other people, you're done. And the C4 model diagrams are a great way to do that. If you're confident that your design satisfies the drivers, the key architecture drivers, then you're good. There are lots of techniques out there for doing this: architecture dry runs, evaluations, ATAM, TARA, etc. You can be lightweight or heavyweight, up to you. And if you've identified the key risks and you're comfortable with the risk profile of what you're going to be building, then you're in a good spot. So for me, this is my checklist. When I'm doing design, I want to be satisfying these 6 goals. When we can do this, we're done. Let's move on. We've done enough thinking. How do you get to this point? There's a ton of techniques out there. Remember I said that agility requires a toolbox of techniques and practices. This is your toolbox of techniques and practices. Workshops, interviews, talking to people. You've got event storming, event mapping, and domain modeling, and a whole bunch of other analysis and domain analysis techniques. You've got architecture evaluation and reviews. You've got my risk storming, the C4 model diagrams, architecture decision records. There's a whole bunch of stuff out there. And some of it is useful, and some of it might not be useful given your context. But have these things in your toolbox, go play with them when necessary. So we're trying to do some upfront design to create a starting point and set an initial direction, admitting that we are going to have to change stuff later. That's just the real world. We're going to get changes. We're going to get changes through external factors, mergers, acquisitions, new business opportunities. Right? Those things we can't foresee now. So we're going to have a starting point and admit that we're going to need to shift and change direction in the future. And that's absolutely fine. That's the essence of being agile, of course. So if you think all this stuff is useful, how do you practice it? Doing architecture cartas is a fantastic way to do this. Neil Ford has a bunch, Ted Neward has a bunch. I have one you can download from my website. So architecture cartas are a great way to try these techniques out, try the diagramming out, try the risk storming out, and it's a great way to practice your design and communication skills. And that is what I think is missing in the industry at the moment. My closing point is really this: adopt an agile mindset. There's a whole bunch of techniques and practices out there. Use the ones that make sense to you. If you take my diagramming stuff and you find it's useful, fantastic. If you find it's not useful, well, just ditch it, go find something else. We need to, again, think about a starting point for our processes and how those processes and the techniques we use evolve as we progress and learn more. So with that in mind, thank you very much.